All right, welcome everyone. Thanks for joining me here, and thank you to the Yogabyte folks for having me. My name is Travis Logan, and I am the CTO and co-founder of Justuno, a SaaS platform powering on-site messaging, lead capture, real-time product suggestions, and A/B testing. Today, I'll be taking you through some of the highlights of my years as I transition from on-premise SQL database solutions to hybrid cloud dedicated solutions, and all the way to the cloud services you know and love today. Along this journey, we'll discuss my ups and downs with Microsoft SQL Server to my experiences with the fully distributed and geo-redundant database Apache Cassandra, and then on to the very capable Yogabyte database platform. While my first SQL experiences actually started with Microsoft Access, I just aged myself a bit, I'm going to skip ahead to 2006, at which point I have several years of Microsoft SQL Server experience. So here we go. Let me set the stage. It's 2006. Pluto, the icy ball furthest from the sun, that many of us were taught in school to be the 9th planet in our solar system, has now been declared a dwarf planet and has been declassified as one of our major planets in our solar system. Italy has also just won the World Cup in Germany. Meanwhile, it's 10 a.m. and I'm gearing up for a very long day in a Los Angeles data center where they keep it below 50 degrees Fahrenheit, and you can't hear yourself think over the thousands of servers and infrastructure fans spinning constantly. I mean, I'm talking, it was loud and cold. I'd wear gloves, a beanie, noise canceling headphones, because I knew I was going to be there more than an hour. I'm about to set up my very first active Microsoft SQL cluster. I've wheeled in my 2 beefy Xeon Dell servers, along with a very expensive Dell SAN server. That's a storage array. I have a bag of cables, some OS DVDs, and insanely expensive licensing packs, and a few Dell support phone numbers ready to tackle that setup and claim my victory. Well, 12 hours later, I was headed home without a SQL cluster up and running. But the good news is I was told by Dell before I left that they would have an updated patch for me in the next day. Well, tomorrow rolls around and Dell came through. I had an email with a patch attachment, and a few hours after getting back to the servers, I now have some serious bragging rights. Time to clear the air on what an active SQL Server cluster is and what it isn't. Yes, the SQL Server nodes are redundant and do have automatic failover, more so as a result of Microsoft Windows failover cluster that you have to set up as a prerequisite to the SQL Server failover that's installed on top. But the first problem with this redundancy is that it relies on a single SAN storage array. In my case, this storage array had redundant power supplies, redundant SCSI network cards, and had 14 very fast 10K RPM drives with 2 hot spares. Keep in mind, 10K was, they had 15Ks, 10K was still the one to have from a cost perspective, and SSDs had just come out and were very cost prohibitive. So while this is in theory very redundant, it's still technically a single point of failure inside the rack. Speaking of the rack, I had redundant network switches and power strips. Of course, another redundancy issue was in my single zone setup. Everything was in a single zone in Los Angeles. Had something happen to that infrastructure, I had no redundancy in place. Now that active is really 2 active failure clusters that mirror each other, where each cluster is an active instance for one or more different databases than the other, and each are failovers for their mirror. So hopefully that makes sense. You take an active failover and an active failover, do this. They're both an active failover of each other, but for separate database instances. So you had to segregate your data into at least 2 different databases or 10 different databases, but either way, different databases had to live on the different clusters. So you had to change your app to pull data from one cluster and other data from another cluster. Hopefully that made sense, but I can explain further later if necessary. With this system, I was finally able to schedule OS and SQL Server updates without too much downtime. And I say too much downtime because it would still take about a minute to fail over a cluster successfully, of which time the app would be down. And I probably will have lost some hair on the top of my head each time as well. I will say that it wasn't until years later when I was only using this particular setup for some personal projects that the SAN had a catastrophic failure, leading to several disk failures at once and ultimately no data. So let's move on to 2009. Barack Obama was elected and has just begun his first presidency term. The same company I set that cluster up for is growing exponentially, and we are quickly approaching both the processing and data capacity of this cluster. We know our hardware is aging, and it's time to look at our options. Here's what we know we need. We are heavily using SQL stored procedures and thus didn't want to rewrite our app for another database. So we were prepared to stick with Microsoft SQL Server, not to mention we had already purchased these very expensive licenses. This time around, we wanted a solution that we could stay and grow with that didn't require myself to gear up for the Arctic like weather and waste hours in commute to and from that data center, and that's even if I was in town to do so. At the time, Microsoft SQL support in the true clouds as we know today was extremely limited. Although Amazon EC2 servers were an option, but the storage capabilities didn't allow us to set up the active clusters we were in need of. Then there was the upcoming Azure, which was still in beta. It had Azure SQL, but it lacked many of the SQL features we were currently using. So a lot of them were around our bulk importing from our app, exporting, and I believe there was quite a few built-in SQL functions that we were going to have to write or rewrite as well. So it would have been a big rewrite, and again, wasn't much of an option because of that. Plus, we already owned those expensive licenses, and you couldn't transfer them to Azure SQL. You had to start paying the SaaS licensing fees that were built in. At the time, there was a new landscape of these custom hybrid cloud platforms that let you do some things from our control panel while also giving you the flexibility of on-premise servers. In comes Stratascale with an offer we couldn't refuse. It was too good to be true. Stratascale offered the ability to vertically scale any of our app or SQL Server cluster nodes on the fly by simply spinning up a new bare bones server and then detaching the logical storage devices from the existing nodes and reattaching them to the upgraded nodes. This was music to my ears, and they even offered to set up the initial app and the SQL clusters. Agreement was signed and we didn't look back. I remember them showing us these really fancy storage arrays that were huge, and they had many of them. I couldn't count how many little lights from disks that were spinning inside those arrays. I remember them saying that you could take a machine gun to this array and the thing would still be running with the loss of any drives that gun hit. So we were off to the races with them. Okay, so most of the promises were kept, and we were in fact able to easily scale our infrastructure as needed. But it didn't make up for the new nickname I received over the next few years that I call the Dark Ages. Sorry, but I can't tell you the nickname as it's kind of profane. And so seeing that wonderful, amazing, ginormous storage system they use to power all their servers quickly became a shared customer nightmare and would constantly go offline. One time it was almost 36 hours before we were back up and running. And you know, after 1 or 2 hours and you hear we're working on it, we might have identified the problem at best. you start to ask yourself and each other, should we just bite the bullet and spin up new servers that don't utilize, in this case, those storage arrays, and load up backups, our most recent backups, so we have an app that's running. Yes, it's gonna not have recent data, but at least we'll be up and running. And then you've got to weigh, the time and effort that's going to spend to do that versus the possibilities of when they're going to get your system back up. And naturally, there's downhill effects too if you do that, because you're running off stale data and so forth. So we pretty much always decided to wait it out. I'm going to go back now, actually, because in tandem with that company, back in 2011, I started my current company, Justuno, as a side gig. But I had it running on just one server that shared both the app and the SQL-related duties, because we were a Bootstrapped team and every penny counted. Thankfully, I built it in a way where all the profile data stored per website visitor was stored as first-party cookies. So it didn't take much to power it. And it got us all the way to 2015 when we became profitable. We already knew we were missing out on the data game and knew we had to jump on board. We wanted to build a DMP of sorts to power our new visitor profile system so we could learn and create AI-driven apps to utilize the data. We knew it would have to handle hundreds of millions of profiles per month, leading to billions of requests, while being able to scale horizontally with maximum redundancy. All of the profile queries would have to also be served in as near real time as possible, so latency was incredibly important. Enter my first experience with Apache Cassandra. Yes, I had some experience with some other NoSQL databases like MongoDB and Redis, but never anything with the prowess of Cassandra. I still remember the first time we load tested a fairly small Cassandra cluster with our app, and we just kept turning up the load, and we were blown away with the results. I also remember the first time we had to add some nodes to it and how easy that was. We provisioned a server, then ran some config scripts of sorts on the OS, applied our internal VRAC IPs, and then joined the node and waited for it to get to a state to take requests. I knew I'd never go back to a non-scale distributed database again. We've spent a few years now with Cassandra, and I'm still overall really impressed, but I do have some gripes. Probably not so much about or with Cassandra itself, but more so about the nature of its key value store or how it was implemented. Moving from a SQL to a NoSQL meant taking much of what we had learned regarding optimizing schemas for reduced data replication and using joins and secondary indexes to efficiently join data across tables, and taking all that and flipping it upside down. Cassandra reteaches you how to approach data and constantly emphasizes that data storage is the cheapest commodity when it comes to servers, and they're right. They emphasize to create as many tables with the same data but different partition keys as necessary to satisfy all your different types of queries to that data. This does introduce some other issues though, like keeping your data in sync across those tables. I remember too that they said, yes, we support secondary indexes, but we don't suggest you use them. The other thing is that they suggested no more than 2 terabytes of storage per server. And that was only if using SSDs or NVMe drives. Then came the reality that of the 2 terabytes, we could only safely use 50%. Otherwise, we ran the risk of not being able to finish repairs. And that brings me to repairs. Actually, I'm going to skip repairs, as that's probably an entire presentation of its own. But I can tell you, sometimes they run successfully, sometimes they don't. Sometimes they take easily north of 24 hours to do so. And we ran into a few circumstances too where there were some versions we were stuck on for months that we couldn't successfully complete a repair and we ended up having tons of tombstone data that was getting undeleted as a result. And I know there were a lot of people in our position at that time just waiting for that update. Earlier this year, we began the quest of building a modern infrastructure for our newest platform. We knew we wanted it to be on Google's cloud platform, and that any part of it had to easily scale out on demand. We wanted to keep as much of it as possible in the Google family. We inherently thought that the more of it that's offered by Google, and the easier setup, the easier maintenance it will be in the long run, in the short run. We hope to power our newest visitor profile off of a SQL database to relieve ourselves of the constant ETL jobs we had to write and run to answer questions from marketing. Marketing, because of that, marketing there was some contention between the marketing department and our dev team. And it's not like marketing wasn't asking for things they shouldn't ask for. It just was quite a bit of work each time. So we first assumed we'd be going with Google Spanners database and their GKE clusters for our app services. After some performance testing, we were very surprised at the high latency that Spanner had with very little data, and that coupled with the extravagant costs of it led us to explore other databases. I'll skip over all the other databases we tried, but we ultimately landed on Yugabyte DB. We have ran extensive load testing with our new beta app powered by the Yugabyte DB, and it just continues to impress. We wanted to make sure with our new platform that we, at a minimum, could handle 50,000 requests per second while maintaining a sub 10 millisecond per request average. Keep in mind, our app is also very heavy in writes. It's almost a 50-50 write and read. And Yugabyte averaged 2 to 3 milliseconds, and which was much better than we had hoped for, along with the ability to, while running a load test, quickly add nodes and remove nodes and see how that impacted during the process and how it impacted after the process. So this was definitely by far the largest load testing strategy we've ever had. We're talking months. And Yugabyte was there at every step of the way to help us answer questions and facilitate any optimizations and such. So kudos there. This database checks all the boxes we had, and then some we didn't even know we wanted. We are talking SQL again, yay. 2 millisecond average query transactions under heavy loads. Continuous availability, globally distributed, built for the cloud and our GCP. It comes with health monitoring, alerting, and backups, and the easiest cluster management interface I've ever had the pleasure of using. As an added bonus, we were able to use Janus Graph with the same Yugabyte cluster as its database to power our AI product recommendations app. That was made possible because on the same cluster, we also run a Cassandra-like YSQL database, all managed from the same easy interface. In a nutshell, we were able to consolidate 4 different databases from our current platform into just this one Yugabyte database. I wanted to thank you all for listening, and I hope you all be safe and have a wonderful day. Thank you.